Here we have to find the value of the limit x tends to 8, x power 1 by 3 minus 2 by x minus 8. Now we'll use L'Hospital rule to solve this. So it is nothing but differentiating the numerator and denominator separately. So if I differentiate x power n, it is n into x power n minus 1, and differentiation of 2 is 0. By differentiation of x minus 8 is 1. Now as the limit is tending to 8, we'll substitute the value of x as 8, which is 2 cube. Now the value of the limit is 1 by 3 into 1 by 4, which is 1 by 12. That is option B. In this problem, it is given that z is equals to x plus jy, where j is a unit vector and x and y are real numbers. Now we have to find the value of modulus of e power jz. Now we know that z is given as x plus jy, so we will substitute them. That is equals to e power xj minus y, since j square is minus 1. Now this can be written as e power minus y into e power xj, which is equals to e power minus y into cos x plus j times of sin x. Now we know the formula e power I theta is nothing but cos theta plus I sin theta. Similarly, e power xj will be cos x plus j sin x. Now modulus of any real number is nothing but root over square of the first real number plus square of the coefficient of imaginary number, which is cos square x plus sin square x. Now that is nothing but e power minus y, which is option D. The given matrix is A is equals to 6, 10, minus 2, minus 3. Now we have to find the trace of A power 10. Now first of all, let us see a property. If A is any matrix whose eigenvalues are lambda 1, lambda 2, lambda 3 and so on, now then trace of A power n will be nothing but sum of all the eigenvalues raised to the power of n. So lambda 2 power n plus lambda 3 power n plus so on. Now in order to find the trace of A power 10, first we have to find the eigenvalues of A. Now in order to find the eigenvalues, we'll consider 6 minus lambda 10 minus 2 minus 3 minus lambda is equals to 0, which is nothing but the characteristic equation. If we simplify this, we'll get lambda minus 2 into lambda minus 1 is equals to 0, which is nothing but lambda 1 is equals to 1 and lambda 2 is equals to 2. That is, the eigenvalues are 1 and 2. Now according to the property, trace of A power 10 will be lambda 1 power 10 plus lambda 2 power 10, which is 1 power 10 plus 2 power 10. That is nothing but 1025, option D. It is given that a coin is tossed 4 times. We have to find the probability of getting exactly 3 heads. Now we'll solve this problem by using binomial distribution. Now here the total number of times a coin tossed, that is n, is given as 4, and we need the required probability, that is getting heads thrice, so r is equals to 3, and x is nothing but the probability of success. Success is nothing but getting a head, which is 1 by 2, and y is nothing but the probability of getting a failure, which is again 1 by 2. Now we need p of x is equals to 3, which is given by the formula ncr into x to the power of r into y power n minus r. Now we know the value of n, which is 4, then c3, x is nothing but half cube into 1 by 2, 4 minus 3. If we simplify, then the value will be by 4, which is nothing but option A. In this problem, it is given that the rank of a matrix 5 by 6 matrix Q is 4. Then we have to check which of the following statements is correct. Now let us come into the statement 2, that is option B. Q will have 4 linearly independent rows and 5 linearly independent columns. Now as the rank of the matrix is 4, either the number of rows or the number of columns will be always less than or equal to that rank. So option B is not possible. Now let us look into option C. Q into Q transpose will be invertible. Now Q into Q transpose will be 5 into 5 into 6 and 6 into 5, which is nothing but 5 by 5 matrix, but it may be invertible, may not be invertible. Look into the option D. So option C is not correct. Now look into option D. What is he saying? Q transpose into Q. Q transpose will be 6 by 5 and next is 5 by 6. So it will be a 6 by 6 matrix, but we cannot say whether it may be invertible or it may not be invertible. So we cannot say correctly that Q transpose into Q will be invertible. So even option D is not correct. So the only option left is A. Let us look into this problem. A rectangular timer beam is to be cut out of a cylindrical log whose diameter is D. Now we have to find the depth of the strongest timer beam. Let us consider a circular beam. Now let us consider a rectangle inscribed inside. The diameter of this circle is nothing but the diagonal of the rectangle, which is given as D. And this radii will be D by 2. Now, by using the properties of triangles, we'll get this value, breadth of this rectangle as D by root 3. And by using Pythagoras theorem, we'll obtain the length as root 2 by 3 D, which is nothing but option B.
Okay, now we will look into the problem. The problem is something like this. In a closed or helical spring is subjected to an axial load. So it is subjected to an axial load. The spring stiffness coefficient we can consider it as K. Let we take, and the other quantities are remaining the same. That means all other constants are remaining same, and the only diameter is doubled. That means what is the relationship between stiffness and the diameter in a closed coil helical spring? Then the stiffness is directly proportional to d to the power of 4. Let me take first stiffness coefficient is K1 and first diameter as D1. Now the second stiffness coefficient we can consider it as D2 and dt is doubled. That means D2 D1. So K1 by K2 is equal to D1 power 4 by D2 power 4. Now K1 from this equation, K2 is going to be 2 power 4 into D1. That is going to be 16 D1. So it is directly increasing 16 times. So option D is correct.
A fixed beam with span L, fixed beam and span L, and it is having a moment capacity MP. We have to find out the ultimate central concentrated load. So the fixed beam, the moments are going to be MP on this side and MP on this side. MP plus MP is equal to central concentrated load P and L by 4. So we have to find out P. P is equal to 8 MP by L. So option D is correct.